Hello grade 8! So today, we are going to talk about our lesson number 3, which is entitled The Difference of Two Squares. Last time, you already know how to factor the common monomials. So you also introduced the GCF and the polynomials. So this time, we are having the difference of two squares. So let's start learning. In this lesson, you are expected to factor completely the different types of polynomials. We are done with the common monomials, the monomial factors, and now we are on the difference of two squares, or the sum and difference of two squares. So let us proceed. Factoring polynomials, or the difference of two squares. As stated here, for a binomial to be a difference of two squares, two conditions must hold. Number 1, there must be two terms that are both squares. Examples are 9a squared and 25, and 81 and x squared. How can they become both squares? Let us see. So for 9, when you find the square root of 9, our answer is 3 because 3 multiplied by 3, the answer is 9. Same goes with 25. So we have the square root of 25 is simply equal to 5 because 5 times 5 is equal to 25. So next is that we have here the square root of 81. So square root of 81 is simply equal to 9 because once again 9 multiplied by 9, our answer is 81. And same goes with square root of 1. Why square root of 1? Because we have here x squared, and automatically, even though you can see the 1, there's 1 actually there. So square root of 1 is simply 1 because 1 times 1 is equal to 1. So the second condition is that there must be a minus sign between the two terms. Okay? So in other words, if x and y are real numbers, variables, or algebraic expressions, then x squared minus y squared is simply equal to quantity x plus y multiplied by quantity x minus y. Once again, in words, this is the difference of two squares of two terms is the product of the sum, here's the sum, and difference of those terms. Let us have examples. Number 1, we have here x raised to 4. X raised to 4 can be expressed as this. So we have x squared, quantity squared, because x squared multiplied by x squared is equal to x raised to 4. You simply need to add the exponent. Okay? So next, we have here 16b raised to 6. So our answer is, you need first to find the square root of 16, and that is 4. Then the square root of b raised to 6, and that is b cubed. So we have here 4b cubed, quantity is squared. And once again, when you multiply 4b cubed by itself, 4b cubed, the answer is 16b raised to 6. So let us try to factor each completely. Letter A is that we have here 4a squared minus 49. Once again, the first condition is for you to know if the two terms are both squares, because when we find the square root of 4a squared, so 4 or the square root of 4 is simply 2, while the square root of a squared is simply a, because a times a is equal to a squared. Now, another is the square root of 49. So the square root of 49 is 7 because 7 times 7 is equal to 49. Now, the second part is you need to just simply put the plus and minus sign. This is the sum and difference of the terms. So we have 2a plus 7 multiplied by quantity 2a minus 7. As simple as that. So another example is this. We have 9x squared minus 25y raised to 4. So once again, we need to find the square of the, or make sure that the two terms are both squares. So we have square root of 9x squared is simply equal to 3x because 3x times 3x is equal to 9x squared. Another is the square root of 25y raised to 4. So the square root of 25 is simply 5 because 5 times 5 is equal to 25. Then the square root of y raised to 4 is equal to y squared because y squared multiplied by y squared, the answer is y raised to 4. So for our final answer, again, you simply need to put this plus and minus sign because this is the sum and difference. So we have here now 3x plus 5y squared multiplied by quantity 3x minus 5y squared. So let us have example C. So we have 81 minus 4p raised to 6 q raised to 4 is equal to, once again, find the square root of 81. So the square root of 81 is 9. And the square root of 4p raised to 6 q raised to 4 is simply 2p cubed q squared. So 2 times 2 is 4. P cubed multiplied by p cubed is p raised to 6. And q squared multiplied by q squared is simply q raised to 4. So you can get the answer. So with that, we can say now that our final answer would be the 9 plus 2p cubed q squared quantity multiplied by quantity 9 minus 2p cubed q squared. Just please don't forget the plus and minus sign or the operations. Okay? So for letter D, we have here 20x cubed minus 5x. The question is if both of the terms are squares. Okay, since not, we can use our knowledge in a common monomial factor. First thing is you need to find the GCF of 20x cubed and 5x. And that is, of course, 5x. Next is that to divide the GCF by the both terms. So we have the answer 4x squared minus 1 as you have learned in our previous discussion. So if you want to check this, you can actually know if your answer is correct by simply using the distributive property. So we have 5x multiplied by 4x squared, so our answer is 20x cubed, and 5x multiplied by negative 1, so our answer is negative 5x. So now, as you can see, 4x squared minus 1 are both squares. So we can actually now use the difference of two squares method. So we have here the square root of 4x squared is equal to 2x, and the square root of 1 is equal to 1. So in that case, we have now 5x multiplied by quantity 2x plus 1 multiplied by quantity 2x minus 1. Okay? So what you applied here is your knowledge in common monomial factor and of course the difference of two squares. So as stated here, you have to express the second factor as the difference of two squares. Of course, as always, there's a problem solving involving polynomials. So let us see. So all you need to do here is to write a polynomial for the area of the shaded region. Then factor completely. So the shaded region we have here. You can see that on the slide. So for our solution is that we need to find the area of the larger rectangle. And that is, of course, in finding the area, we know that area is equal to length multiplied by width. So our larger rectangle is, the length is 7x and the width is x. So 7x multiplied by x, our answer is 7x squared. Okay? Next is that we need to find the area of the smaller rectangle. Once again, area is simply equal to length multiplied by the width. So our length is 7 multiplied by 4, which is the width. Our answer now is 28. So the next thing you need to do is for us to subtract the area of the smaller rectangle from the area of the larger rectangle to find the area of the shaded region, of course. So, our larger rectangle is 7x squared. We need to subtract the smaller rectangle, which is 28. So, we can actually now use our knowledge in factoring polynomials. So, as you can see, 7x squared and 28 are not both squares. So, we can use the common monomial factor. So, the common factor of 7x squared minus 28 is 7. So, 7x squared divided by 7, the answer is x squared. And negative 28 divided by 7, you got negative 4. So, once again, you can use the distributive property if you want to check if your answer is correct. So, x squared minus 4 is now both squares. So, the square root of x squared is simply x and the square root of 4 is simply 2. So, don't forget the plus and minus. So, you have here now 7 multiplied by quantity x plus 2 multiplied by quantity x minus 2. So, always remember and keep in your mind that if x and y are real numbers, variables, or algebraic expressions, then x squared minus y squared is simply equal to quantity x plus y multiplied by quantity x minus y. Once again, in words, the difference of two squares of two terms is the product of the sum and difference of those terms. So don't be confused, have fun, and enjoy learning mathematics. So thank you and God bless.